Yeah.
Mike, you get jealous because you get so many emails?
No, I'm just trying to concentrate and the screen's going, and this sound's coming. You gotta learn to work with distractions.
Seriously.
I think once you have a child, the whole games change, right? So now I'm used to like somebody pulling me here while I'm typing and stuff. So, and especially he's teething, so he's biting me. So I'm like, he's biting me. Anyway, so we'll continue with the synchronization aspects we're talking about. Right? Synchronization, as we're kind of alluding to, is the hardest part, the part that makes multimedia stuff worth talking about, right? Especially for most of the, I think going forward, it's not so important to worry about how to encode video, how to transmit video. I think MPEG-4 is fairly good. H.264 is fairly good. You can stream contents, you can get contents, and what have you. But what is lacking is ways to collaborate, ways to merge streams, ways to do stuff, right? And one of the my pet peeves with all these technologies that we can work on is, I get to travel being a faculty once a month, which is still annoying, right? Most of you, when you get papers and stuff, you have to travel, right? And most of the times when you travel, there's the social component, but most of the time you're doing stuff that you would like to be able to do it remotely, right? If you're trying to have a video conference and try to say little stuff, right? And if any of you have tried one of those techniques for doing these things, they are really, really lacking in most stuff, right? Though I think the only thing these things are good for right now is distance dating, right? Where you don't really care about the quality of the video. You're kind of willing to accept doing this stuff. How many of you actually tried video chatting, audio chatting for loved ones kind of thing? If you tried those, you're willing to tolerate a whole bunch of stuff, right? So if you can't see your loved one for a little bit, you're okay. If you can't hear them for a little bit, it's okay. Because you're willing to tolerate, because you just want, especially if you're in the college setting, you want the cheapest price, right? You just want something that sort of works, right? But when you're trying to get work done, when you're trying to, so for example, if you want to see, there's a conference going on right now, I want to see what's going on in the conference, right? I require some good quality. I require ability for me to talk back. I require the ability for all of us to participate and feel reasonably like we were there, right? And the most of the systems that we have right now is one person talks and then the other person talks. Everybody else has to stop. You have to have some kind of a remote coordination, some distributed coordination going on where I say, okay, now it's going to be me, I'm going to talk, right? And then at the end, I'm going to have to say pretty much like over and out, and then somebody says, okay, now we have to start kind of thing, right? And those kind of things get bad really quickly, really soon, right? So, but those sort of stuff, I think is the future. You know, trying to make these things, trying to make more complex stuff is what we're trying to look for. And so the synchronization plays a big role in trying to make these things and define what they are and go from there. Right? Am I still making noise? Or?
Yeah.
So continuing on, one of the other forms of synchronization is whether we are talking about two people, synchronizing with each other as a video conference, audio conference, whiteboard kind of applications, or whether you're talking about a group collaboration, right? Either in real life or fictitious synchronized like a video game, right? We are both going into a virtual world where both of us don't exist. So you have to project me into the virtual world, project you into the virtual world, and all of us into this virtual world where we do stuff, right? This particular area, there's a lot of interest. There's lots of money in this stuff, both from the video game perspective and from the corporate teleconferencing stuff, right? And the HP project that we'll talk about tries to get into this world, right? people apparently like to be in a video conference where we have video conference not in a gray area like this, but we all virtually go to Hawaii, sit in the beach, and have a meeting and feel like we were there, right? And how to get there, how to do those stuff is what people are looking at. And in terms of synchronization, there's either the notion of a live synchronization where we are doing a video audio chat, or synchronizing where it's synthetic, synchronizing where you add other components as things go along, right? So for example, think of so if you're playing video games, one of the things we can do is you can have these different avatars or different objects on your DVD. So when your game starts, you can read the contents off of some of these devices to perform the next operation, right? So when you're playing video games, you're essentially not streaming everything to everybody else, right? So you're only streaming me moving, and the other person knows what the room is, what everything is, either because they have it on their local DVD or it's streamed offline, right? Being able to synchronize those is important, because now you have to deal with the fact that suppose I go to a new room, right? If all my friends don't come into the same room quickly because their DVD player is slow or still reading contents, then I lose continuity, right? And a lot of these things sound like they're very video game-ish kind of thing, but that's a really big market. That's a really big stuff. And I forget, like, how many of you actually play video games on a remote video games? What is your experience with the game quality so far?
With game quality or with the interaction voice chat?
Explain what is voice chat. I don't play.
Well, you were talking about a group collaborating through.
Yeah.
Often we'll use a separate program for most of our collaboration.
Okay.
Than the actual game program itself.
Okay.
And so, for instance, you'll use TeamSpeak, which is a voice chat, or even something like Skype with multiple people.
Okay.
In order to speak back and forth.
So you have two channels. So one channel is the Skype, and then the other one is the game stuff, right? How synchronized?
First of all, the voice chat doesn't have to be exactly on time with the game interaction.
Okay.
Because as long as you're within a half second or so, that's usually enough.
Okay.
And it's also useful.
So you usually get half a second?
No, usually it's slightly better than that. Usually it's about 200 milliseconds.
You get 200 milliseconds worth of coordination between the game and the separate audio chat.
And it's also very useful because if one of them fails, the person can tell you, oh, I went down on such and such. I'll be right back.
Okay. Is that?
Yeah, that's what I do too. My friend and I usually play on a team in like enemy territory, and we'll use the game.
Okay.
And then just use Skype for our team operation.
Okay.
That's pretty cool.
Is that?
I don't usually use voice as much, but I use more thinking about, like you get lag every once in a while where people start moving around.
Mm-hmm.
But what you were talking about, like going into different rooms and stuff,
Mm-hmm.
I know a lot of first-person ones pretty much keep everything open
Mm-hmm.
so that there's no new places to
Oh.
live. So it's all one big
Mm-hmm.
level.
So I was talking to some of the people who are really into the multimedia, what's that, MMORG, right? Multimedia online role-playing games. And they said it becomes like very interesting if you have 50,000 or so people out there. I mean, it's kind of boring if you're playing role game with like 2 of your friends. But if you have 50,000 people out there to scale with where everybody's in this one big room, right? It only works if you're doing networking at Notre Dame, right? It doesn't work otherwise. So you have to go into separate rooms. So you want all these people out there, but you want to have a bunch of people go off into a separate space, and then you go back into the thing, right? I have never played a role-playing game. It sounds not that interesting, but how many of you actually played multimedia role-playing games? I heard it's like really addictive, right? So there's some people from Korea who were in the conference, and they said basically their biggest social concern is kids from the 15 to 18-year-old don't exist anymore, right? Because they all, from home, after the school, they just go back and then they're gone because they actually live in this virtual world, right? Yeah, and they said it's having a social impact because the kids just kind of vanish because they all go into this virtual world, and apparently it's not so true in the US, but Korea and Japan, they said it's like really, really popular kind of stuff, right? So
people over there, they'll play the game for like 48 hours and die because
And-
they can't eat or drink anything.
yes, and
There's a couple of people like that in the US too.
Yeah.
they're professional players too, right? Professional players, and there's TV channel, and actually we have TV channel here too, right? On at least on Dish satellite, there's a high definition channel which only shows game programs.
G4.
E3, I think. No, no, not G4. This only shows game. I just watched for a few seconds, right? But you only see the games going on, right? So I thought I was like past the generation which plays all this stuff, and they're like, no. I mean, these are very addictive. Once you get used to the stuff, then
Even in some situations that like just chatting gets addictive. Like I remember back in high school, we would like call my friends and say, okay, let's go online to see what we're gonna do. Then end up just chatting for the next 4 hours, and it's like, oh, we're not doing anything now. We're going to bed. Things like that. It just happened to us very often. Just
okay.
we went online and just spent hours and hours on end doing nothing.
And everybody outgrew it, and you never chatted anymore.
But I mean, so no, they were not talking about like one-on-one. I mean, they're talking about like forming a large group, right? Like not small thing, but like 50,000, 100,000 users playing role-playing games, right? So if you haven't like played those things, and if you have a video, like I don't know how you play those games, but you should try it because I mean, at least to see what these things are, right? So anyway, so like you have to like as a technique. So we will read some of the papers on what people have to do to get these things going, because when you're talking about 50,000 players playing, where each one of them have their own, the very very tight latency requirements, right? And when you think about these are multi-billion-dollar industries, you want to solve these issues, right? So the book talks about a couple of different variants of the live synchronizing. Yeah, so where you're doing video chat and stuff. So there may be spatial skew where the image itself is made smaller. So the synchronization becomes a lot easier because you have fewer pixels, right? So you can also think about live synchronizing with the temporal offshoot, because if you're recording, right? So if you're stored and playing these contents, then the timing requirements are a lot more strict, because on the stored contents you want the things to be synchronized, right? And I was actually watching CNN, trying to like turn up or have the volume low and then look at the lips, right? They're horrible, right? They're really, really bad. It's really obviously bad because the guy was talking and the sound was like very off, right? So if you have CNN or something, just watch the sync, right? It's not close to 20 milliseconds. It looks like it's like a couple of seconds off kind of thing. But I guess no one watches CNN and like sits there and like looks at the player, right? He's kind of in the background. You're kind of like TV, airports or something. You're just hearing the sound and kind of stuff. So it's kind of okay, but it's really awful, right? So I'm gonna again continue to go through what is in the textbook in terms of how these things are done. I'm gonna only go through a very high level overview, right? And as you would imagine, the problem of synchronization first you have to figure out what are the different components involved, and then trying to synchronize with them, right? And that may or may not be as trivial as you would imagine. So for example, if you have a synchronized content on a hard disk, right, And meaning like, if you play from a hard disk, it's tuned such that all the things we talked about in terms of where to place the contents, the object placement and the hard disk and all was all fixed. Now if you move it to another medium like DVD, right, all bets are off, right? Because the seek times on a hard disk is a lot different than what you have on a DVD. So when you move to a DVD, whatever was synchronized no longer is synchronous, right? You might have noticed. So if you're playing a DVD and if you stop and go to menu, right, you'll notice it's a pretty slow process. Your disk stops and then like the lot of noise. It takes you a few seconds to go to the menu, right? Whereas in a hard disk, if you do that, it's acceptable, right? So if you have a lot of interactions on your DVD stuff, if you have lots of menus and lots of little buttons that you can click, right? You know what I'm talking about, right? Like the DVD have all these different menus and stuff. You look very. So you have all this like little menus and like things you can press, right? And too much interactions on a DVD is pretty annoying because the medium is not designed for seeks. I mean, it's pretty good if you start the movie and start playing, everything is fine. But if you have lots of interactions, if you want to play a game using DVD media, it's pretty annoying because the seek latency is quite high. So those are considerations you have to work on. So you not only do you have to worry about synchronization, but also on where this is going to be stored and how this is going to be used. And you can't just move them across different devices because they all have different characteristics, right? So to understand this as more of a science and trying to figure out what that is, you need to develop a reference model. You need to develop a model of what are the different levels of synchronization that you want for the different components, being able to specify what they are, being able to specify the relationship between each one of them, being able to specify what are the tolerances, right, and being able to see if your system can support some notion of quality, right? So you're going beyond the notion of I want a good experience, I want a good video, to being able to specify these are a set of things I want to happen, right? And that's the notion of reference model. You want to have some model to say, if you can implement this reference model the way I defined it, then that's good, right? So anytime you fail, I can see how far you are off from my specification, right? And when you're doing the specification, I want to be able to say all the other things we talked about in the last class. Like for example, some of the stuff, 80 milliseconds is okay. So I want to be able to specify that too. To say, if you're off by 80 milliseconds within this video, that's still acceptable. So my reference model has to include all these specifications and so on, right? So one of the book talks about as a 4-layer model, right? The different layers are the media layer, stream layer, object layer, and the specification layer. And each one of them talks about something more complex. So the simplest form is the media layer, and the more higher level form is the specification layer. And we'll see what the different layers are, right? So essentially, if you define this layer, and if you define what each of your objects mean for each layer, and if you have all the 4 layers, that defines how you want this media experience to be for the end user, right? And then you can figure out how good you are to that particular stuff. So looking at each one of those layers, media layer is essentially you treat each stream separately. So if you're talking about video and audio, you treat audio here or video here, and you use all notions of quality of service we talked about before, right? So if you're talking about, let's say, video, then you have to define what a LDU, which typically be a frame, and then you define what kind of compression you want, how do you store the objects, where do you put this, where location and what have you, for a video such that video can be played synchronously for a particular system, right? It only talks about each stuff separately. So you would figure out how to store video, you would figure out how to store audio separately by itself. No synchronization between any one of them, right? And this is practically what we did for the first few, actually most of the lectures, right? We look at each one of them, figure out what is the quality of service for each one of them. And at this point, it's dependent. it's device independent, right? You're not talking about how these things collaborate. So this is the stuff we have done so far. The next notion is you define how these different objects try to correlate amongst each other as a stream notion. So if you're talking about audio and video, how do they interact with each other into one stream, right? There are implicit temporal constraints, because if you're talking about audio and video, these two have to be in synchronization. But it doesn't have a higher level construct. So you're not talking about audio, video, and another object. You're not talking about audio, video, and an image, right? So if you're talking about a DVD movie, right? So if you look at the menu, right? The menu has one movie going on, and there's like a operations. You can move the thing, choose the play or chapters or what have you, right? You're not talking about any of the interactions among those. You're only talking about audio and video for a particular scene. How do they play, right? The next level of description is the object base. So you kind of say, now I have a video object, now I have a URL object. So when the user clicks this component of the screen, it has to go to this web page, right? So the object is, there's a video object which has video and audio. There's a URL object, there's a link object. How do those interact? What happens? What is the latency between somebody clicking something and then going off, right? And the specification layer, which is the higher level layer, which ties all these things together. And the different ways of specifying these stuff, right? So, for example, we'll see a little bit more of the details in subsequent slides. But essentially, here you would talk about temporal relationship between these things. So you say this sequence will follow after something. This will happen before something. You can specify them based on some virtual time scale. This is sort of like the music notes. The orchestra notions can be control flow based on if after somebody clicks this, something happens, and event based and so on. So if you want to get a feel of what these are, think of what YouTube does, right? So when you go to YouTube, right, you see a screen, right, with some video playing, and there are little controls at the bottom, there's play or what have you. And then once the video ends, you see, it has this where to go next, right? It shows two different stuff, right? How many of you remember what I'm talking about? You can actually go here, right? I guess the wireless is not.
Start downloading a movie. Really sick to it.
I have no idea what these are.
There's 27 objects, items.
Oh.
Get a Bill Hicks video.
Maybe I should use the Ethernet. No, I switched to Ethernet. Maybe I should.
Use wireless.
No, I tried to go to the. I turned it up because I was hoping to use the Ethernet. This is the problem with live demos, right? Nothing.
Reading something in French. Oh, okay.
Ah.
What does it do? Oh,
I'll try for a couple more seconds.
Done it. You killed the internet.
Realizing distributed video was a lot of our bandwidth.
Apparently not.
No, they killed the wire network.
They thought we'll torture you. Kill the wired network and use this wireless.
I'm on wireless, but now I can't see. I guess I'm not getting a DHCP address or something.
Close the browser.
Yeah.
What?
You have to close the browser. It may not be smart enough to
No, it
sign the connections.
Okay, I'm going to try one last thing.
You want to implement.
I do have IP address. Okay.
Those two people look like Jeff Goldblum.
Yeah.
was Jeff Goldblum.
The guy from Malcolm from Jurassic Park.
Oh, okay. Yeah.
Did other stuff too.
That's my mouse.
Using The Fly and The Fly 2.
I've never seen that movie either.
Oh, that's
Better
awesome.
movies than this. The poor guy. We just can't think of him.
He like arm wrestles this guy and breaks his arm. Like right here it breaks. Cause he's half fly. He's like God.
So,
fly.
hopefully this will come up eventually, right? But what you see in YouTube is actually a flash animation, right? All the things that you see is a flash animation. So it's not actually playing a video alone. It's playing an animation where network is not very fast, but all the things that you see here is it's a event. It's a object, right? Is anyone getting a network which is slightly faster than this one?
Are all the landlines on the same network too?
I can't. I mean, I tried this. I mean, they have this Ethernet here, right? But apparently that doesn't go anywhere, right? So these.
It's like a wire.
Yeah. So these objects that you see, right, are part of your flash animations, right? So the flash includes all this. Actually, I think it includes this stuff too, right? If you click on the ratings, it takes it, right? So it takes the whole thing as a flash, and it defines these buttons for pause, what have you, whatever, right? So you have to define what happens when you click this button. You have to define when you press this one, when you move the slider back and forth. And you have to first have network, but and what these happen, right?
We're at least getting some video from YouTube.
What's the advantage of doing Flash over something else?
They have control over all the stuff. Flash is not just a video. Flash is the specification I'm talking about, right? So Flash includes the video which comes here, which is encrypted using whatever. I mean, let's say H.264 or whatever, right? H.264 defines what comes up here, but Flash helps you define all the stuff.
But why not just stream the media directly and let your local player handle it?
It prevents people from downloading the video from the servers.
I mean, is that really all it is?
No, more than that, right? Unfortunately, I can't show this
Down
stuff.
around the new stuff.
So after you're done, right, like if any of you can play this stuff after this video is done, you'll see there's 2 advertisements here, right? Saying like what else you can play, right?
Print screen.
How many remember what I'm talking about? That's essentially what I'm trying to show here, but this network is not showing. So after the video is over, it'll show you this little two things, 2 related things, and that's what keeps YouTube kind of addictive, right? Because you see those things here, like, okay, let me watch one more video, then I'll go off, kind of,
Yeah,
right?
that's what happens.
And those are actually objects. Those are actually hyperlinks to objects, which has this little video, little pictures, relationships where you can click and all those things, right? So those you're defining because so essentially Flash is not a streaming video. Flash defines this whole thing, right? And I don't know what happened to this stuff, but
What error?
It's the fly.
I mean it's completely stopped, right? So if any of you go,
Oh, I'm getting a video, so.
you are.
Yeah.
So at the end of the video, do you?
It's slowing down.
I don't actually want to see the video because I want to see what happens.
Exactly, okay. You put on
Yeah, it's right.
it's like blah.
But whatever the time hasn't.
It's very.
So after you finish your video, can you see your screen?
It's being very slow, but.
One terrible frame.
And apparently this is not something that we're going to solve, right? Because we're solving something else, right? The networking part. So anyways, I'm going to go. So if your video ever finishes, I want to borrow your screen for a second.
That's the one I
So your point is that Flash is a example of a specification layer?
Of the whole multimedia experience that I'm talking about, that you're trying to define here, right? They have defined, so implicitly, explicitly, they have defined in the specification layer what comes before and what comes after. So the first thing which comes is you see this video, you see this screen, right? So you define the spatially what happens. You define that your screen will look like this, where there'll be a video here. At the bottom, you'll have these, player control with a forward and stop and all those things. Once that thing finishes, you will then transition into another screen where you have this advertisement, 2 advertisements on the top of related objects that they can stream to you at certain instance. So this has to happen after the video ends, right? And those are different objects. Those are, one is a video, one is like these buttons and stuff. So after this, you come up here. So when you click on this stuff, when you have a pointer, right, which has to behave a certain way too, right? So your pointer has to, when you move around this stuff, right, your pointer has to appear where you expect them to be. And then once you click on it, right, then you transition to the next object, right? All those specifications are what I'm talking about, right? So when you talk about the media layer talks about how this streaming should happen, right? And how this pointer should move when you move over it, right? So if you go to YouTube and you move your pointer on top of it, all these events are actually going to the Flash, right? And the stream layer will tell you how these things are streamed, how the video is streamed to you, how the audio is streamed to you. And the object layer tells you what these different objects are, the video object, then the advertisement object, and so on. And high-level specification is what ties everything together, right?
Are there other examples other than Flash? Flash is the main one.
There are other more research-oriented systems which can do a lot more complicated stuff. Flash is a lot simpler so Flash, I was going to show Flash because I can actually show it to you without actually me defining all the stuff. Your textbook has a whole bunch of other things which talk about more complicated stuff, not just animation, web browsing, and all those things. Whereas Flash is one thing that you can see because YouTube is actually taking through all the stuff, right? Unfortunately, did it ever finish?
No, it stopped like halfway through.
Okay, so some of you go
it's like it's slowly, like every few seconds, like another second of the video.
Okay, so just go. When you go home, go play through YouTube. Not because YouTube is anything, but because this is what I'm talking about. You have this whole system, and what we are looking at is how do you define these stuff so you know how bad it is. Like for example, at this point, if YouTube was to analyze what William is seeing, they would say you are providing really bad because our specification said this is what should have happened, right? And what he is seeing is so much horrible. How do you define how far he is off from what they intended, right? And that's the notion. Rather than saying it just sucks, being able to say which component is bad, right? Now, I apologize I didn't realize the network was like that bad, and so maybe I will send a mail back to them again saying your problem is not just your stupid multicast packets, it's other stuff. Yeah.
Do they ever use the wireless themselves?
Apparently the guy does, and that's why he's looking for this roaming thing, because I don't think anybody else should be worried about roaming, right? I think that's a lot easier to tell users, right? So if you go from DOM to depart low, your network will be completely different, right? You can still continue to work, but some of the things will fail. You'll see different things, right? That should be easier to tell to students, right? I don't think that should be I don't think students should demand that I should be able to go anywhere in the campus and still continue to have the same IP address, right?
I don't think they care.
I'm saying the students should not care, because students should not. I'm saying it should be easy to teach the students, right? That when you go to a different building, things will be different. You can continue to initiate new stuff, but the old stuff will fail. So if you have SSH running when you're in DOM, when you come to school, things will fail, right? And that's that. I mean, I think students are smart enough to know that component, right? And we're being driven by this because apparently that's a hard thing to explain, right? But I don't think that's. I mean,
It's just he's just selfish and he wants one big network for him to travel in.
Can you just not understand how to break it up?
no, but he was like, we were sending emails and he was responding back saying like,
Well, it did finish.
Okay, so
It does seem to show some stuff on it.
yeah, like this part, like so I don't know if you can see. I'm gonna take this down. Right? Actually, it's coming slowly. see the same thing flashing, right? It's not supposed. I mean, I never seen it flash. It usually kind of.
It's flashing through different ones too.
Because I think it's trickling in. Because it hasn't even finished the video, because it says 208/245, so it shouldn't have even finished. So you shouldn't be even coming up to this screen, but because if I go by all the specification, right, it should say after you finish the movie, show advertisement, not halfway through the movie. So it's showing some blinking stuff, but like this is the different object I'm talking about. That's the next object that you want to play. And obviously, if you give the specification, this is clearly violating whatever YouTube intended, because events are happening before they should, right? And they're also happening in a flashy way, but blinking way or whatever you call it, right? Right. So all this stuff is trying to show how those should be done, and some of them are obvious for us to see. I mean, you can say after you show the video, show the advertisement, right? That seems fairly obvious. But it goes beyond that, because like remember the things we said about what's the correlation between text and video, how far they can be. They should all be part of the stuff, right? Obviously they didn't intend to be running on our wireless, because this is hopelessly off, right? So once you have the specification, how do you send it to the user, right? So once somebody defines these notions of what should happen afterwards, they have to be sent to the output devices. So because they are the ones who are going to render this. So for example, in his case, the flash player has to be told that here's a bunch of objects that will be sent to you, but don't show the advertisement till the video is over, right? Or if the user clicks something, don't do that, right? The specification can be sent to you. So we can either have the specification sent to the clients and then start the transmission. You can have them sent along with the stuff, and I think that's what is happening, right? So his advertisements are there before the previous video is over, and since the specification hasn't come in yet, it's showing the advertisements when it should have waited for the stuff, right? I'm just guessing, but depending on, so if you send them separately, then you would run into a problem like what he's seeing, right? Or you can wait for all the specifications to be sent before you start anything. And one of these things work depending on what you're trying to do. If you're trying to play a video game, I can send all the stuff up to you, all the rules up to you before I might start, because otherwise it's kind of annoying, right? I forget what website, but there is one website which is actually running a distributed shell on using Flash, right? So you actually log into this website, you get an account, then they have something like a Word and all those things. All of them are Flash stuff. I forget what I got an account. I started working in them and I forgot what they are. You remember?
I don't remember, but I remember my friend showed me this like Windows, and you could like completely interact with like an Apple
Yes.
kernel or something.
Yes.
It was, like,
It's all Flash. Yes. So actually, you can get. I think it's part of the Web 2.0 some site, right? I forget what the site is. I got an account, and if I remember, I'll bring it back. But essentially, they have a screen, and it looks like you have the start and everything. You have applications you can start, and you can have web documents. You can have spreadsheets and all those things. But they're all Flash animations,
and
right?
even the dashboard, like, you can scroll perfectly, and it's like
Yeah.
perfect quality.
Yeah, I mean, of course you have to have network, not this one, but no, but it's surprisingly so. Unless you know that this is Flash, right? You can't tell what the difference is. I mean, you can actually type words and it'll save and all those things, right? And it was really nifty, really nice, and I forgot what that website is. And so that's being pushed as the one which will kill Microsoft, right? Because essentially, then you can log in anywhere and you have this desktop, right? And so, but forget about what it's supposed to do, but it's essentially a Flash animation, and you have to create all these rules, right? So when you're trying to create more complex websites like that, you need all the specifications. It's not just a simple show video. It's where they're placed and what's the temporal relationship, right? And the third notion is multiplex, where they multiplex it and send it to you, right? So when you get this stream, you get these three things multiplexed. In a simpler format, where you can tell the difference is QuickTime actually sends the video and audio and the control in separate channels, right? So, and they come in different ports, right? So if you have a machine where you know how to play with the firewalls, you can block off certain components and let the other things go through, right? So for example, you can cut off the audio, and since audio is a separate channel, right, you'll just see the video without the audio coming through because it's completely being blocked, right? Or you can have all of them. So Real does this one. Real puts everything into one packet. So the source itself mixes all these things together. So when you get the video, you have no control over separate channels, right? So again, if you're talking about synchronization based on time, right? One of the ways is to have all these machines time synchronized. So if YouTube was to say, now play this video, right? It can either say after 2 minutes play this stuff, or you can say at 1:33 play this content, right? In that case, both these clocks should be synchronized, or else you'll have bad stuff. And there are ways to synchronize clocks, right? The ways to synchronize clocks, and the problems of having distributed systems where the clocks are synchronized is a general problem for all distributed systems, right? Your OS class should have touched on it. I think the undergrad OS class briefly touched on it. The grad OS class will probably dwell more into this construct, right? It's very hard, and if your application do require it, then you would have to worry about those, right? And again, all the issues that you would face with the distributed systems apply here. Again, in terms of the kinds of stuff I can do, it can be 1:1, where one source and one destination. You can have, one source, many clients, what you would look up as a server, many sources, one client, right? Where you're trying. So this is sort of the model that you would use if all you had is sort of like Planet Lab, right? If you want to get a high definition video over Planet Lab, then you would use multiple Planet Lab machines, each one of them streaming some of the contents to you. You put them all together to make a high definition video. And of course, the holy grail is the N:/M, where there are multiple servers, multiple clients. Each of them can interact with each other, right? And sort of this is the model that you would see for a video game, right? Where you have a bunch of people all playing. They're all sources. They're all recipients. For generality, you can assume that some players just watch rather than participate, right? And in terms of synchronization, the book talks about multiple different ways of, steps of how you would synchronize, right? So, for example, you have to synchronize while acquisition is happening. So the video camera figures out how to synchronize the video and the audio, right? And then you have to worry about where they are synchronized, when they are stored, when they are transmitted, when they are received, when they are played, and when they are played, the output device, how they synchronize, right? So you have to define what those things are. Many of them you don't have control over. So when you buy a video camera, it says the audio and video will be synchronized up to 80 milliseconds, right? So you have to take that into consideration when you build these systems. And some of these manipulation operations get really iffy, right? So if you go back to your YouTube, you can press the pause button, right? And it may not have any effect immediately. You can press the forward button, right? And actually, I think like sometimes the cursor keeps going back, right? So essentially, if it starts to play, you can buffer all these contents. But if you want to do these manipulations, then it has to rebuffer, move things back, and you see a delay, right? And what happens and how those things are is the next problem you want to look at. And again, there are a lot of issues, and hopefully you get a sense of the different kinds of problems that you run into, right? So if you're building a distributed system, you have to consider the aspects of the distribution, right? And there's no better example than what happened when I tried to show you the demo, right? Because the network itself is so horrible that all the things that we know don't work anymore, right? So if YouTube was to design a system, they have to assume a certain network and they have to worry about how the system works. Obviously, no one can design for how our particular network is set up, but you assume a realistic network, right? And most of us use YouTube, and it's fine, right? At the rate that we are seeing today, it's so unacceptable that no one would ever use YouTube, right? And then you define the notion. So you have to assume that the kind of network. You have to assume inter-object, within the synchronization between the audio and video and between different objects. Then you have to define what is intended application. So if you're talking about production level or presentation level, the idea here is if I'm recording a video to be shown, if I'm making a movie, right? Then I'm looking at a production level because I want to store this contents and show it to a different bunch of people. So the SKU and all the things I'm worried about is a lot more stringent because I want this to be a master copy for a whole bunch of users, right? Whereas if it's a presentation level, then I'm willing to tolerate a lot more failure because I don't expect this stuff to be useful for anybody else, right? So, for example, if I want to record a movie, I want the lip synchronization to be absolute or as close as possible. Whereas if I'm showing it to a user, I make compromises based on the network conditions I have. So these define what happens. So, for example, the YouTube model, right? They're optimizing for presentation level, whereas your camcorder will be optimizing for production level, where the synchronization is a lot more important because you expect further operations on those objects. And what this means is you cannot get, if you want the kind of production level quality that you desire, you just can't do it on a network setup. Right? Because if the network is not fast enough or good enough, it may not be able to give you what you want. And then based on, so then you specify the different SKUs we talked about. Depending on the audio and video, we have different levels of SKU, right? This we looked at in the last class. So given these requirements, you may be able to infer something else, as a simple correlation. So if you know that audio and video, what ratio they can be, you can figure out what the video to pointer to video specification. So you don't want to specify everything, so you can infer some of them based on something else you do. A truly good production system should be able to infer all the stuff and figure out what are the tolerances that it can deal with. Right? So in terms, one of the things that we mentioned was interval based, which says that one happens afterwards, right? That seems simple enough, where I say after you finish the video, show the advertisements or what have you. But if you think about it, depending on the number of parameters that you're willing to tolerate, that will translate into a whole bunch of other components, right? And the book has good visual examples to show what happens. So for example, before, this happens before may mean that the transmission should complete before something happens, right? So if you have two video clips, right? If you expect the first video clip to play and then the second one to play, right? Depending on what they are, you can either say after the first one finishes, the next one should have at least had one frame, right? So you can continue to play, right? Or if it involves both of them. So you have a whole bunch of different ways of stating the fact that one should finish and then the next one should go, and depends on the object, right? Does that make sense? See, in terms of the advertisement, right? You have to have the first one finished, and then at least the first frame of the next one there, so it can start playing. If it involves controls, if it involves a new playback or pause button, then you have to have all the code for that particular operation sent before the end of the current sequence, because otherwise you can't display the controls, right? So depending on the object, you would have to define these relationships, and the book talks about different steps. So when whoever designed this YouTube, right, depending on how powerful Flash is, they would have to define each operations not just as one happens before, but how much of the code has to be on the other end before some things can proceed, right? I'm going to actually stop with this stuff, and let's continue back from the next lecture. But so the simple, and hopefully I'll have the YouTube things cached. I can show some of this different stuff. But so any production facility has to define all this stuff and be able to specify this is what we wanted, and then the problem of how do we get it out to the other side so they'll play, right? And some of this stuff may be intuitively obvious to you that you don't actually specify all the stuff. So if you did generate DVDs using iDVD or something, right? You just put menus, you just put buttons and stuff, and it intuitively seems to you that it should all play, right? Because you don't actually think about all the stuff, but a DVD player has to define all the stuff. They have to know that when you press the play button, then it should, there's something going on. There's a CD, the disc is moving. It should start playing. And what is the latency that you can expect and all those things, right? And within the tolerances, it plays whatever it has to play. And the whole thing we're looking at right now is how do you specify it? How do you make sure that it is within the specification? So I'd like to continue with this again in next lecture, and before we wrap this up. Okay. And again, apologies for the demo, if spending time on the demo. I'll see you on.
Okay, it's OIT's fault.
What?
It's OIT's fault.
No, so now I actually think that I'm going to actually fight with them, because this is unacceptably poor behavior, right? So I don't want them to kill wireless to solve the problem of too much traffic.